We are now moving and dealing with our last topic in limits for the year, which is called limits at infinity. Limits at infinity deal basically with us finding horizontal asymptotes and slant asymptotes if they exist. Now, it's going to be cool. If you actually look at some graphs, they act like there's parabolic asymptotes, although they reserve asymptotes for lines. So now in our first graph, what we're interested in is what's happening as we're going to infinity. So as I'm heading towards infinity, over here at the end of my graph, my answer is always -2. So my answer as x approaches negative infinity, the graph is approaching -2. Now, as I go to positive infinity, which is at the end of the graph, I see that this side is always going to +2. Now, these are the only questions they tend to ask about these. These can be equal or not equal, but we don't say what's the limit as I go to plus and minus infinity unless we give the same answer. And so at the end, this is going to head towards -2 as it is at the beginning, but just to let us see. Now for the next one, we want to ask the same question. And so I'm interested in what is happening as I head to the far left as I'm heading to negative infinity. And it looks this time like as I approach negative infinity that I'm approaching the horizontal line 0. I'm not going to touch it, but it looks like that's where I'm heading. Now for this one, this is meant to be like a square root graph, folks. And what happens? It is heading ever so slowly, at a snail's pace, at a turtle's pace, towards what? Negative infinity. So as I approach positive infinity, that is, as x gets bigger and bigger, y is getting smaller and smaller and smaller, ever so slowly. Now, when I look at my next two graphs, this one you can see is a basic cubic function. And as I move this direction, what's happening? I see my y's are heading down towards Satan very quickly. And so as x gets very small, y is getting very small. As x heads towards negative infinity, y is heading towards negative infinity. And as x gets very large, what's happening to these x? They're heading heavenward. They're heading up. And so that would be positive infinity. See, it's just the end behavior of the graph. What's happening? Now, for the next graph, I gave you a quartic function, a cute little w. See, 1, 2, 3, 4 roots. What's happening as I head this direction further and further? Well, as the x's get smaller and smaller, the y's get larger and larger. And so this is heading towards positive infinity. And over on this side, as the x's get larger and larger, the y's are getting larger and larger. So the end behavior, again, is both ends are positive infinity. Now, this should not be a shock. When I give you an odd function, one end is going to negative infinity, the other end to positive infinity. And when I give you an even function, either both are going to positive infinity or both are going to negative infinity. You learned that in Algebra 2. So now let's look at a parabola, absolute value, which is another even function. Notice an absolute value is similar to a parabola in its behavior, in that its end behavior as this end goes to negative infinity to positive infinity. As these x's get larger and larger and larger, these y's get larger and larger. It's an even function, an absolute value. And you should have learned about even and odd functions. And so it's going to be positive, positive. Now, an oblique line is just an odd function. One end is going to head towards negative infinity, the other end towards positive infinity. It just happens as x is getting smaller, so is y. And so it's heading to negative infinity. And as this x is getting bigger, so is the y. And so this is going to positive infinity. Now you should stop the tape and you should try the next page by yourself to see how you do, and then check where you're going to be and come in return and see what's going to happen. So now when we come to this next grouping, notice we've got the little horizontal line in here to help you. But as the x's get smaller and smaller, what are the y's going towards? Well, they're going to, but not crossing, where y equals 1. So on the left side, as x heads towards negative infinity, my y values are getting closer to 1. On the right side, as I'm heading towards positive infinity for the x, getting larger and larger, my y's are approaching but not crossing the line y equals -2. Now, this is a hyperbola, folks, and you're used to seeing this. This is just a hyperbola that's been twisted. We're used to seeing them in the quadrants, or a little better, more symmetry for us where they go through. But anyway, it's just something called a rotated hyperbola. Now this is just a weird graph to show you, what can happen. I mean, there's a vertical asymptote in here. I mean, I'm thrilled. And I can see it's dipping and doing all these little curly cues here. But all I'm interested in is over here. What's happening as my x gets smaller? Well, I see that my y's will not cross the line -1. They'll get ever so close to it, but they're not going to cross it. On this other end, what's happening? As I get closer and closer and closer and head on that way, I can see that my y's are not going to cross the x-axis, and they're going to get closer and closer to 0. And so the other one was a little cutesy, so here's another cutesy one going the other direction. And you say, oh no, I crossed the asymptote. We don't care. Asymptotes don't care what happens in the middle. It's like there's no asymptote technically in the middle for many graphs. We're only interested in the very end. So as x approaches negative infinity, what's happening? We can say, oh, I'm dropping down to, but I'm not touching the line y equals 2. So I'm stuck there. Now I got a vertical asymptote. I can say, oh no, it's negative. No, 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 no. I don't care if it's negative infinity. That's not as x is approaching positive infinity. Notice on this side, this one is not coming. This one was from above, but this one's approaching from below and will not cross the line at 2. And so as x approaches positive infinity, we're going to 2. Now here's that infinite vertical asymptote one that we go through that involves an infinity. Now here is the issue with this one. It depends on how you read this graph, and because Mr. Hatt and I stole this one offline, you have two choices here. Some people think if it looks like it's curving here and it didn't keep on going, but if you think it's curving here, you could say, oh, wow, it's equal to 3. Or some people think, oh, it's going to just keep on going up. It's just, like this, but ever so slowly you see the curve is still just ever so slowly. And then some people say, well, what if, because there's lots of room over here and it didn't show anymore, what if this graph is just stopping there? So you could legally, because we don't know the intent, tell me, oh, I think it was approaching the horizontal line 3 right there, and that's the reason, it stopped. Or you could have told me you thought it was going to positive infinity. Or you could simply say, oh, there is no limit because it doesn't go there. The limit just does not exist. I mean, there's not going to be any kind of a horizontal or oblique asymptote. From that, it just ends. And so there would be nothing for negative infinity. We don't know what to tell you. I mean, it's just up to you. Now, when I look at this one, it's just an oblique ray. And so as the x gets big, the y's getting big, and so we're heading to positive infinity. Now, for the last couple, again, we're going to now see a function where this one is just oscillating. It looks like a sine curve of some sort. And actually, it looks like sine because this could be 3.14 and this could be 6.28 going through, and it's the sine curve y equals x. What happens, it just keeps going up and down. And so we ask, what is this going to be? And some people just write, well, there is not one. Other people would say write D and E. Again, this is personal choice. It's just as I go to infinity, there is nothing. Or again, you could say D and E. We accept both answers when we go through. Now, the last one on this page, number 12, again, we don't know what's happening here. We don't know, does this mean it's going to keep on going down? Did it just stop? Is this shape going to keep on going? Is it going to change like this? We don't have enough information. So again, we could say none, which is the squiggly line, or you could say does not exist because I don't know. Over here, I can see the shapes are going all over the place. I don't know. It didn't go down the paper and tell me that it was officially going to stop there. So you might say, oh, I think it's heading to negative infinity. I mean, we don't know. But the intent of this one, again, we believe was probably none, or one does not exist. Okay, for the last page, we're going to come back to a couple of normal ones before we go back to the weird ones. And this is kind of a little bit of a review. You see a horizontal ray, an oblique ray. What is happening here? It's always -3. So at infinity, it's always negative infinity. It's still going to be -3. This one is essentially 1, -2. You can see it's 2-point-something 0, but as x gets big, y gets big. And so this one's heading to positive infinity. Here's another absolute value. It's an even function. No matter which infinity you're going to, heading left or heading right, the y's are going to head up towards heaven. For number 15, as I just look at the end behavior, we've already dealt with the first worksheet we dealt with what was happening in the middle. But as I look at the end, both ends are heading up. And again, it's an even function. It's an absolute value. It acts like a parabola. And so either both ends go up or both ends go down. We have a hyperbola. Now this is one like you're used to seeing. Here's a nice vertical asymptote and a nice horizontal asymptote for both. As x gets smaller and smaller, the y's are you're approaching 0 as you're heading towards negative infinity from above. And on this side, you're heading towards 0 as x approaches positive infinity. Nice hyperbola. Last two. When we come to this one, not sure what it is, but I kind of have an idea of some things it could be. But all they let us see is this side, and it looks though this is an asymptote, and it's just heading further down. So we would conclude that as x is getting small, y is getting very small. And on this side, as x gets large, y drops down but doesn't cross, and I think that's -2.5. The line -2.5. Now, we're going to end on one where we can't draw a conclusion again. It looks like on this side, maybe it's going to just keep looking like these shapes. Don't know, and then that would be oscillating, no conclusion. But then it could, I don't know, maybe it turns into this shape. But what we don't know is this going to keep getting smaller and smaller and smaller and smaller to eventually you could say it's going to be 0. We don't know because we don't have enough of the graph for either of these to draw the conclusion. So we can say none, squiggly, D and E. And for the other one, we can say none, squiggly, D and E. We just don't have enough information to see. This side you might conclude, but over here we just don't have enough information to see if we can make a more in-depth conclusion. So this is our first worksheet. Hopefully you can go through and you can make sense out of this again for yourselves. The next video that I do is going to be very long and messy as I show you what a calculus teacher would demand that you do, because this is the beginnings of calculus. But then I'll show you what we allow you to do. That, let's say that this question was a multiple choice question on the AP, then you wouldn't have to do what your calculus teacher demands. So next worksheet video is going to be probably longer than the last ones have been lately. So good luck.